welcome everyone. So today's webinar is particularly looking at weather forecasting opportunities, I guess more localized weather forecasting opportunities for the vegetable industry. We've got a special focus today on New South Wales. That's where this project is being undertaken. But we're actually taking some, I guess, opportunities to learn from what's going on in Tasmania particularly, and what that may look like in the future in New South Wales if we were to sort of take up some of those opportunities. So hopefully everyone can share my screen. This project in New South Wales is currently supported by the New South Wales and Australian Government's Storm and Flood Industry Recovery Program. It is an 18-month project, and we're 1 year into it. So I'd like to thank all our supporters of today's webinar, which is James Weather, AgLogic, and also Caitlin from Redco Ag. And I'll just give you just a brief intro to this project that's been running in New South Wales. It is specifically around resilience and improved biosecurity during and post flood events. We also have been looking at other extreme weather events, such as drought and winds, those sorts of things as well. We've been identifying the main risk pathways that facilitate the spread of pests and disease into and around the farm post weather events and during weather events, and trying to come up with some good strategies to help growers with that. And we've been also then getting out and about and communicating practical ways of actually addressing some of these challenges. We've also been specifically really targeting supporting those who support vegetable growers. So a lot of agronomists and agency service providers across the state. So we've been having workshops, running drop-in days, running free diagnostics programs, and also introducing them to the new technologies and information that's out there. And today is really part of that. I'm Marguerite White, the project coordinator for this, and I've also got Rose. She's on board here today, who's the program biosecurity program manager with AUSVEG overseeing this project. So first of all, we're going to have Josh Cross and Jane Bunn from Jane's Weather, and they'll talk on the platform that they've actually developed and growers have really commenced using around precise and actionable weather insights. So it's really about hyper local weather forecasting, and they'll introduce that to us, what the possibilities and capabilities are of that. We'll also take an example of how equipment in the ground is informing the models of Jane's Weather, and how it can work on a big regional scale. With Marek from AgLogic having a chat to us about how that's happening in Tasmania. And then we've got Caitlin, who's a long-term user of Jane's Weather and also of the network across Tasmania. And she'll actually have a chat to us about how it's really changed the way that she's making decisions on her farm, particularly around crop protection, and using the data that comes from Jane's Weather to really evidence what she's doing for programs such as Fresh Care, which I think is really important. So without further ado, I'm going to stop sharing my screen and we'll pass it straight over to Josh and Jane to introduce us to Jane's Weather and the benefits in hyperlocal forecasting.
Hello, everyone. My name is Jane Bunn. I am from Jane's Weather, founder and meteorologist. We also have Josh Cross on the call, who is a business development manager and client liaison to make sure that you get the most out of the platform that we are developing. What we're aiming to walk you through today is how you can use our precise and actionable weather insights to get the most out of what you're doing on your farm. So let's go through what we have here. We've got two farms that we have as an example within the weather data we're going to have a look at today. Josh, would you mind just briefly giving us a little bit of an idea about Sam and Ed and how they came to be and where they are?
Sure. Hello, everybody. Josh, James Weather. We've used Sam's Farm and Ed's Farm for an example for this presentation. Sam and Claire's farm is about 2K away from the Richmond bomb station. So
So
throughout,
just in the Western Sydney basin there.
correct. Yep. And Ed's farm is just out in Cowra. So Ed's had a wild eye weather station installed. So this is an example of if you do have someone like AgLogic weather station network or a weather station supplier install a weather station. Ed's farm has a weather station. Sam's farm is using an official weather station or a bomb weather station. So that's why we've used Sam's farm and Ed's farm as two different examples for this presentation.
Fantastic. So I'll keep this fairly New South Wales oriented today in terms of what weather is coming up. So you'll also get a bit of a weather forecast out of me. But we're going to sort of demonstrate how we can really help you out with rain, frost, spraying, irrigation, winds, and growth, and many other metrics that we have here at Jane's Weather. It's all about making sure we can see what's happening on your farm in terms of having a weather station, so observations of what has happened, and then applying that to make it a hyper local forecast for your spot. So I'm going to start with just a bit of an idea of what our platform at Jane's Weather looks like. Here is our forecast page, which is generally where you will begin, and I've chosen Richmond, so you can see, so just in the Western Sydney basin there. On the left hand side, we've got our summary for the week ahead, and if you click one of these here, you can get a bit more info. This is what we call our threat toolbox. It's kind of like all the things that you need to be potentially concerned about today, the things that can get you. And so what we are known for is making sure that you've got at a glance decision making capability. So it's all color coded if it's going to be a concern. So our temperature, it's all on a legend there, so you can quickly see what is likely to happen when a cool change is coming through and that sort of thing. What the winds are doing, so you can quickly see again if it gets up to breezy or strong or gale because the colour changes. Our spraying conditions, that's not just delta T, but it takes into account winds, it takes into account temperature inversions, temperature, rainfall, cloud cover, all of these things to give you a yes or no on whether you can spray. So that's where we find our summary detail and also our threat toolbox. But in the main part of the screen here, we've got our weather worm, but it's the weather graph, and it shows you hour by hour what's likely to happen. So here is what the cloud is doing. Again, this is for Richmond. We've got what the rainfall is doing down the bottom. There'll be a bit more exciting rainfall to show in the days ahead, and also what the temperature and the weather icon is likely to be, plus our wind here. So this is an easterly wind, and it is light. I'll just pop that up so you can see the thing there. It is light to moderate winds today coming in from the east. So this is Richmond today. We're around here. If you look at the different spread of the weather model, so I've got our Pro toggle on. Here is our AI forecast, which is a summary of them all that has taken into account observations in the area to make it hyper local. But if you expand this toggle out, you can see all of the different guidance that goes into making up that decision. Looking at the legend here, we've got models from Australia, Canada, USA, and Europe. These are global weather models. So they map every single part of the of Earth and then provide a forecast for that grid square. Now, in Richmond, this model here, which is the USA, that one has it being a lot hotter than what the other models have here today. So you can quickly see how varied the guidance can be. And the red line is our AI forecast that has learnt from observations on this particular site and has adapted the forecast accordingly. All right, so today, not a lot of wet weather, but we'll just jump into Thursday. So then this is when things get exciting. Dry all through the morning hours, in the afternoon and evening. We have the risk of thunderstorms, temperatures start to drop. We don't have strong winds, they continue to be quite light, but in the afternoon and evening, showers and thunderstorms are likely to be moving through the area. Sunny in the morning, cloudy in the afternoon. So that gives an idea. Now let's pop over to Cowra that I've picked up there. This one is now just the other side of the Great Dividing Range, so in a very different weather situation. So here we have today, we've got a fair bit of cloud in through there. There's some very light and patchy rain to the south that isn't quite making up here. Only one of the weather models has that particular instance. It dries up in the morning, and then tomorrow we've got cooler conditions, but again, we're missing out on the rain. If you look at this summary here, there is pretty much nothing coming to this area over the next 10 days. So that gives you an idea of what weather is likely here just on that side of the ranges in comparison to Richmond in the Western Sydney Basin. 10 millimetres is the average for tomorrow, and we've got 13 as the total. So there's some wet weather coming in here. I've also got Coffs Harbour. No, I don't have Coffs Harbour. Yes, I do. There it is. Coffs Harbour, which is also seeing a bit of a different pattern. 4 millimetres tomorrow, 12 the day after, a little bit more to follow in through here later in the weekend. So that's 29 millimetres as the forecast. Let's just unpack what all of that is doing. And here are our maps. So that was looking at a particular point. This one here is having a bit of a broader look at what is likely to happen. This is our AI forecast, and it is the total rain for the day. So here we have Wednesday that we're looking at there. So this is that light and patchy rain band that I've been talking about here. I'm just going to zoom in to the New South Wales area so that we can see that a bit tighter. Cowra missing out, and the Western Sydney Basin also missing out today. All of that activity is to the south. I'm going to jump forward. So here is during the day on Thursday, so the 24-hour period. Here we have Cowra is missing out on the other side of the ranges, the dry side for this particular example, whereas we've got a big weather system that is working its way up the coast there and also spreading to these inland parts. So that's why Coffs Harbour is getting it, all of these parts are getting it, Sydney is seeing it, but it dries up as it heads further west. So that's Thursday. Heading into Friday, it continues along the coast and moves out to sea. Again, nothing inland. Moving into Saturday, just a little bit in through here, nothing really in the Sydney area. Moving into Sunday, that's when the next weather system comes back. I'm just going to zoom out so we can see that one where it came from. So heading out to Australia again. This one here is Saturday. We've got a nice connection to tropical moisture up through here, spreading down into the south. So there's a trough that's running in through here that is creating that wet weather. But watch it jump. If you're after rain in the southeast, we're not really going to see it. So there's not a lot there, not a lot in through here. It reforms again as it moves into Queensland and that northeastern corner of New South Wales. So that's as we go through the day on Sunday, and then Monday it continues there too. So that's just a bit of an overguide of what is happening across the next week in terms of weather and how that is likely to impact these particular areas here. With that, I will also go into our seasonal outlook just to give you a quick indicator. So currently, here's that trough that's going to be moving into the northeast as we're going to tomorrow. Cold fronts are coming through. Our friends in Tasmania, do look out. We're looking at snow down to about 600 metres by Friday morning. So get those winter jackets back out once again. You'll want that for Thursday and Friday because these guys are coming through. Anyway, so that's what our pattern is. Here's the rainfall totals over the next 8 days. So most of it southeast Queensland, northeast New South Wales, Western Sydney Basin getting it, but not over on the other side. Tasmania mainly plummeting into the west there and drying out as it heads further east. Some other things to have a look at is our sea surface temperature anomaly, how much warmer or cooler the top of the ocean is. Why do we care about this? Because it drives our moisture sources. In order to get rain, you've got to have two things working together. You've got to have tropical moisture and you have to have instability. So this can tell us how much tropical moisture we may have access to. And so this one here turning blue, that's us heading into La Nina. This one here with blue through much of that box, it's a negative Indian Ocean dipole. So that just tells us it's the La Nina of the Indian Ocean. When we have all of this warm water around Northern Australia, that means we have better access to that tropical moisture that can fuel those weather systems. But you only see the rain if it actually moves through your spot. This only tells us about the moisture part of that equation. Heading into the Pacific Ocean Index, so we've been coming out of El Nino. We've been very slowly during the year dropping down. Here we are now as of Monday this week. We've got 1, 2 weather models that cross that threshold into La Nina. There is 1, 2, 3, 4 weather models that go near the threshold. And here is a tip. The Australian Bureau has 0.8, so where that green line is as the official threshold. The Americans have it as 0.5. So you'll hear different guidance from them because 1, 2, 3, 4 weather models will be crossing their threshold. We have 2 weather models that don't like it, but they're just remaining very neutral. Nothing likes taking that moisture away from us from the Pacific Ocean. There's nothing up here in the dry zone. So it's all heading in this direction. It's either a La Nina if we cross that threshold, or it's very close to, which encourages that moisture to come to us anyway. Having a look at the Indian Ocean Index, so that's the IOD, this one is now down in a negative there, which encourages moisture to come from the northwest. And you saw it on our weather maps. Let's just go back to this, how it's pouring in from there and coming down into the south when we've got weather systems to tap into that moisture and turn it into wet weather. So that one dries up pretty soon and the monsoon takes over for summer. Another couple of little things to look at. SAM, the southern annular mode, that tells us whether we're likely to get troughs and lows to turn that moisture into rain, or whether they're likely to be cold fronts. And this dipping down here, that's our front. That's why Tasmania have a very cold end to the week. Heading into the MJO, the Madden-Julian Oscillation. When I'm giving this presentation in real life, I usually ask for a hands up as to how many people have any idea what I'm talking about here. We usually just get 1 or 2 that have heard of this. This one is important. It's a weird name. It's a weird graph, but it's a pulse of energy that travels around the tropics. Okay, tropics, tropical moisture. When that is around Australia, that helps bring that tropical moisture and feed it down into those weather systems. So we care when it's over in the green zone, which is where it is right now, which is why we can get that flow of moisture coming down into the south. So this tells us that for the next little bit, we have a good connection to tropical moisture. As we go into the start of November, we move into a suppressed phase where we're not likely to see that connection up into the north. So that's just some ideas about what you can get from our long-range forecasting as well. Okay, I'm going to head back to here, and with all of what I showed you on the website, it's an hour by hour, day by day, what the weather's likely to do. That's great. It's a forecast. We know it's the best data, but how can you actually use that in the day by day things that you need to do? So I'll get Josh to take over here and talk about the notifications, the alerts you can set, and how you can get some real value out of those ones there. Take away, Josh.
Thanks, Jane. Thanks for the forecast. Beautiful. Again, back to Ed's farm and Sam's farm here. I've just put those side by side just as some real world examples. So for their frost risk here, as Jane was mentioning before, it's one good thing to have the best data tracking, but you've got to present it in a way that you can work with it every day and understand it. So this is, for example, one of our alerts that we've got available in our notifications section. So for Ed's farm here, we just quite simply set a frost risk alert. And so this has been generated by aggregating all of that best weather guidance, bringing all of the data from those best weather models in, and then using AI machine learning to upload Ed's weather station details at Mulyan and adapt the forecast based on those observations and the aggregation of those weather models. So what that means is this chance of frost between 4 and 6 a.m. on Friday the 25th is a very accurate, or a more accurate frost prediction than what you would get if you were relying on, just one weather model or just one weather app or one piece of guidance.
Takes into account not just the temperature, but also what the wind is doing, what the cloud cover is. It's not just is it cold enough, but is it all the right conditions coming together to produce frost on your farm? And just so you know, this is the Cowra, the one that's nearby to Cowra. And also we saw that there's no wet weather coming in the next week, but there is a frost risk because of that cold air that's coming up from Tasmania as we move into Friday and Saturday.
Beautiful. Yeah, if we if there's going to be a chance of severe frost as well, we'll just get a darker blue there indicated in that section. Moving on to the right, we're at Richmond now, and we've generated a spray forecast for Sam's farm. So with the spray forecast, that's one of our advanced variables that takes into account delta T, wind speed, inversions, temperature, rainfall, and cloud cover. just to give you a very easy at a glance decision-making tool as to whether you're spraying, Saturday afternoon or Friday afternoon. Again, in this case, we're also bringing in all of that best weather data. We're aggregating all of those best weather models. Sam doesn't have a weather station on farm. However, he's only 2 kilometres away from the closest official bomb station. So, in his profile, he just is using the closest bomb for local observations, and that's great. That's perfect for him because it is only 2K away. It's at the same height, so he gets an accurate forecast based on those observations as well. Is there anything you wanted to add to that, Jane, before
Just
we
that
move
it's
on?
easy to read. It's a good marginal unsuitable. It's color coded, so at a glance you can see when the conditions are going to be right. Again, not just delta T, but all of the things that impact your spray there. Now let me just move to
I'll just ask a quick question.
Sure.
With that, is there a way of having a look at what climatic variable is driving that the suitability or the unsuitability of spraying? So can you see if it's the wind that's impacting it, or is it the temperature, humidity? Is that a possibility?
Yeah, so we've had a fair bit of feedback there that we don't want just the final solution. We'd like to be able to see what makes up that calculation. And in our next release, that should be coming out where you can quickly see whether, oh, okay, so all of the things are right, but it is the temperature inversion that's the issue. So you'll be able to quickly see if that's what the thing is that's making it marginal, for example. So any API client of ours, you already have access to that, but on our platform here, that's coming soon.
And sorry, with the inversion that you talk about, so are these inversions that we're looking at differential over, say, a 10-meter tower and a 2-meter tower? Is that
correct? Yes.
Yeah.
So it's looking at what's happening at 10 meters versus 2 meters. Yeah.
Yeah, cool.
Yeah. Fantastic. Josh, AUTO?
ETO, so another one of our advanced ag variables available on the platform. I've run these ETO alerts for both Ed's farm and Sam's farm. So Ed's farm being over that other side of the Great Dividing Range, he hasn't got the rainfall coming, but we've got an 8-day total evapotranspiration score for him at 47.3. Ed's going to need to make some decisions on irrigation there. We've also got Richmond, Sam's farm. So we've got that bit of rainfall coming through. So with about the 40 mil expected, combined with our 8-day total evapotranspiration of 40 mil, sorry, and the 13 mil of rain potential, we can do our calculation on what we're doing around irrigation at Sam's farms. Just an example there of how we present ETO and how you
we
can
know
set
that
alerts.
the Cowra 1 has no natural rainfall coming, and this is how much evapotranspiration is likely to be. In the Eastern example, the Richmond 1, there is rainfall in the area, particularly on Thursday into Friday morning. They are as showers and thunderstorms. That is hit and miss activity. So this shows you that there's the potential for, say, around 12 millimeters coming if you are directly underneath one of these cells as it moves through. And so this presents what the evapotranspiration is without that rainfall, but this is the potential rainfall that you have to offset that. And I believe the magic rule here is, say it is 40 millimeters, that's 0.4 of a megaliter per hectare that you need to use over the next week. And growing degree days? And
growing degree days, we can set our base depending on your type of crop. So we can set the base of 0, 5 or 10 degrees Celsius. Again, we've got the two examples here with our cumulative figures for both farms. One set of figures has been derived from an aggregation of the global weather models and the closest bomb station. The other one's been derived by an aggregation of the global weather models and the on-farm weather station. So handy thing with the growing degree day forecast is you can add it to your current tally to monitor your growth and plan your resources around that. Probably Marek could touch on and elaborate on how he used growing degree days, and Caitlin as well later on, if you wanted to as well. So, do you use this metric much with what you're doing, Merrick?
Yeah, definitely. So in the viticulture, it's a massive one comparing year on year in terms of how we're going in terms of maturity. So yeah, great maturity and ripeness in the small fruit industry as well. Blueberries, raspberries, growing to day degrees while it's protected cropping. It's a massive driver for spacing out their harvest loads, making sure that they're getting their pickers where they need to be. And what I'll quickly mention when I'm speaking is the peas as well. So again, getting that forecasting for maturity, making sure that we're getting machines where we need them to be. Yeah,
Nice.
definitely.
And this presents what's likely to happen over the next week. You compare it to where you are, as Josh said, the tally you have. We have also in development. You notice I say that a lot. So we're constantly developing at Jane's Weather. We hear your feedback. We hear what you want it to do, and we make it for you. So we're bringing in growing degree days, what the total is so far this year to this point, or at least since, say, July 1st, and then also what it was last year. So you can compare where we were at this time last year to where we are now, and help with that decision-making capability. So this is the forecast for now, and there is more information to come shortly. Great. And there we go. Josh, a little bit about weather stations.
Okay, so in February we launched Jane's Weather Pro, where we went hyper local. We were after many years of Jane and the tech team slaving away, we can now pair a weather station to your profile, and you can now have custom microclimate forecasts based on, as I mentioned before, the aggregation of those weather models, bringing all that best weather data in, and now having the ability to adapt the forecasts from what the AI machine learning observes at your particular property. So, for example, I've got a few weather stations plotted about the place. It allows me to really monitor those different microclimates. I'm more likely to have frost at this particular part of the property. I'm more likely to have very high winds and be very limited as to spray windows that I've got at another section of the property. So by having these weather stations and being able to have a forecast for these particular microclimates is a game changer now that I can not only monitor and get a forecast for those different parts of the property, but the forecast I'm getting is a lot more accurate more often, because it is derived from all of that best weather data coming in, and then AI and machine learning going, well, the Euro model usually gets it right here for wind, so I'm weighting the Euro model in this case. The USA model gets
talk about that
right.
a little bit in detail there. And to answer Rosa's question, thank you for sending that through. This is essentially our secret sauce that makes this data a lot better. So there are 4 different weather models that are available that operate in the Australian area. You don't need to know anything about them and how they work on your particular spot. Just know that we have collected the best weather data for you and put that together into one thing. So a common practice is I'll have a look at this app, I'll look at that site, I'll look at that app, I'll look at that site. This one says one thing, that one says something completely different. It's because they're all using a different weather model as their base data source. What we're doing is bringing all of that different guidance and showing it to you side by side. So when you looked at the forecasting through here, let's go to these ones here, this showed us that all of these different colors, that is the different output from those different weather models. What's nice about this situation here is they're all sort of starting at the same time. They're all sort of finishing at the same time. So that gives us higher confidence that this is likely to occur as we move through the afternoon and evening tomorrow. There'll be other parts in here where I'll go to Monday. It's got just a little bit of wet weather here, but 20%, 40%. So it's just 1 or 2 weather models that have any wet weather there. The other ones have it completely dry. So what's good about us is we are showing you that data side by side, so you don't have to compare it yourself. The other bit is we take a consensus, so we average all of those weather models, but then the green bar here that you can see on the chart, that shows us that by averaging those weather models, but then bringing in the observations from your site and using machine learning and AI, it goes, okay, so in this particular weather station, it was the Euro model that did really well, or in this weather station, it was this particular model that did really well. And so we hit the mark a lot more often than what the other weather models do because we have learned from conditions at the site. Just another example in here. Here's my farm, which is southeast of Melbourne on the Mornington Peninsula. And here's the global weather guidance. And you can see it's all sitting up here through 15, 16 degrees. But our AI forecast knows that at this particular property, this here is what is more likely to happen. Where we are, we're at 300 metres, so we're up on a bit of a hill. The nearest Weather Bureau station is 25 k's away, and it's right in a maritime environment. So there's no real connection to what's happening at our spot and what that nearest weather station is showing. Now that we've brought our weather station observations in, the AI forecast is usually quite different from what those global weather models are saying because it knows that it cools off earlier, it heats up faster, and it's got a much better handle on what happens at that particular site. So hopefully that answers that particular question. So you don't need to choose the best model. We're essentially doing that for you through machine learning and AI. Into the next one here is what new features are in the works and upcoming. We talked about the spray conditions as marginal, etc. So with that, let me just skip into here and we're going to show you this. So these are all of the variables that we now have developed. Quite a few of them still need to, what we know is come out to the front end so that you guys can actually play with them. But this gives you an idea of all the things that we have here. So temp, dew point, wind, precipitation, that sort of thing. Cloud cover, fog, that's a new one. UV index is there now. Storm risk. So it takes into account, these are the technical things that run into it, Cape K index, lift index, total totals, all of that to tell you if it's likely to be a severe thunderstorm. That could be like Casterton saw last week, where you get incredible hail, etc., or whether it's a garden variety thunderstorm. So that's something that's in development to give better data. With our spraying forecast, it's about unlocking what you can see went into that spraying forecast so you can see if it's which particular one is holding you back. We're doing a dew risk, which not just, we've had feedback that we don't only care about frost, we care about dew as well because we need to wait for that to dry up so we can actually spray things. So that one is coming out. Evapotranspiration, we're doing an advanced level of that, which is currently in development, so there'll be an even better tool to use there. With our growing degree days, we're getting the history that's coming into that so you can get the full picture of what's happening. We also have chill hours and chill portions, so it's not just about the heat element, but if you're growing fruit, you really need to know about those chill hours and chill portions, so we have that for you. Where our weather conducive to pests and diseases. We have downy mildew so far, but there's a list of about 20 of them that we are developing, and if there is something that you get on your farm that you need to know about, let us know, and we will make sure that it's included in the development process so that you can be ahead of this particular thing and get rid of it before it's a problem. Solar radiation's coming in. If your feedlots, heat loading index and accumulated, we've got livestock stress in terms of heat and cold and human as well. And then there are all of the soil temperature and soil moisture, the surface, 10 centimetres under, down at those depths so that you can get a forecast for what that is likely to do in the week ahead to work with your soil moisture and temperature observations that you have coming in. So that kind of gives you an idea of where we are heading in terms of the development. Okay, I feel like it's already 11:40, so I have talked about the weather.
I do have one question though
Yep.
for you, Jane. In terms of your upcoming storm risk alerts, obviously something that we deal with a lot in New South Wales are East Coast lows. And especially sort of from that February to May, it's the period seems to be broadening these days. Will that gets wrapped up in some of those developments that you'll be coming up with in the
Will
next few?
indeed. Let's just go through. I'm just going to jump through in time with the wind that we have down here. So this is one of the big impacts of an east coast low if you are right on the coast, and it is the wind speed and direction and what the gusts are likely to be. And so this shows an example of where we have those problems. I'm also going to go back to one here, which is an example here. So this wind example here. So this shows that this was Wilcannia when a big system came through, and it shows how here we are in our light to moderate. It got to breezy by 6 a.m. We were over that strong threshold, but look how much it jumped up from 10 o'clock onwards. So 83, 102 k's an hour, 101, 103, and then it took this long to sort of properly moderate, and then it wasn't back to nicer conditions until later that day. So this gives you, it unpacks hour by hour what the impact is likely to be on you. This is the wind example. You'd also look at the rain example of what that's coming in to show you there. But another great thing is I do a video every Friday morning. It is me as a meteorologist walking you through the situation at hand over the next couple of days to the week ahead, but also what those climate drivers are doing and how that is likely to impact our weather in the season and the months ahead. And so that gives you a good idea of when these systems are coming in, where they're likely to move, what the latest guidance is showing. And you'll also see it here on Jane's Weather once we bring the pressure element in. And don't worry, I'll be widening this off the coast a little bit more. So that gives you a good idea of where you are in relation to the particular storm that is coming, so the East Coast low, and what impact is going to be on you. So here's just an example of wind. Doesn't have the arrows on it yet, but this shows where the scary winds are. And if we were talking about a low coming down the east coast and you saw that colouring and you were right in that zone, you would know how long that threat is going to be there based on and where it's going to move as well. So that's where we're heading with that sort of information.
Okay, great. Thank you. Because I know definitely it's East Coast lows that have caused a lot of damage to vegetable growing regions over the years, and something that we all wonder how we can, I guess, prepare better for.
Thank you, Marguerite. And so what I'm going to speak about today is, I guess, the sensing side of it. So how we collect the data that can feed into Jane's Weather to give us that hyperlocal that forecasting. Go through a bit of the journey that we've gone through with the Weather Station Network. So I'm part of AgLogic, so I run half of the AgLogic business, which look the sensing side of it. So soil moisture probes and irrigation scheduling is a major part of what we do, but weather stations is another big part of what we do as well. So whether it's private weather stations or part of a weather station network that we have around the state that we got through funding from the drought hubs, or the drought hubs, which are located all over the country. But we were lucky enough to get a project through ours. So I'll start off with our weather station network. So this is it here. So it was funded through the hub and through AgriFutures and a number of other different funding bodies. But the reason why we did this this way was because we started off going. Everyone was talking about drought, and they were talking about sorry, hang on there. Talking about drought and talking about where we should focus everything on the areas around this part of the state. The problem is, though, no one spoke about this area here because all they were worried about was rainfall amounts. And we're going, well, it's not so much about rainfall amount, it's about rainfall variability in our mind. So that was a big driver for us to look at concentrating in the northwest part of the state. The other thing about that is that if you have a look at from the coast and the rainfall on the coast compared to rainfall, which is probably about 30, 40 k's in, you can see how that's fairly variable. And so all throughout that region, they were relying on weather stations, which were bomb stations, which were, funnily enough, located at airports. Now, I don't see much stuff going on tarmac. And so with all that data that was being collected, it was in agricultural black spots. So it wasn't really relevant to a lot of our growers. So things weren't that accurate. And so people were taking the weather information with a bit of a grain of salt. Because, there could be here one place and looking good, and it can be like this somewhere else. So this is a real drive to try and understand that variability and yeah, just get people a bit more relevant data so they can make better decisions. Yes, I'll be talking about the hardware, but the hardware is the means to the end, essentially. What I'm interested in, what I really get excited about is the data and the decision making that comes from the data. Once we can do that, then it's actually, we can see use in it, and it all comes down to ROI. We can see a return on investment. We can see us, making better decisions, making more sustainable decisions, making more money. That's essentially what it comes down to. It's pretty black and white, but how we get there is really important. And the other thing was the lack of decision displayed data. You can jump onto a phenomenal number of apps and weather apps, but how it was displayed for decision making. And that's a really important part of it. So how you collect the data, how you send out the data, but also the interface. You can have the most rigid sensors in the world, but if you can't display that in a meaningful way that can help you make decisions, it's easy to interpret, that's easy to read and take action from, that it's no point. That's where Jane's Weather's fantastic, especially in the way that they take on feedback in terms of how farmers want to see the data, use the data, and make decisions off that data. So that's a really important outcome. So just a bit of a background with the weather station network. We started off with 6. So these 6 regions here, and that came from the AgriFutures fund. So 6 weather stations. As you can see, a lot of them were further inland as opposed to sitting there on the coast. And we leveraged that to get more funding in round 1 of our Tas Farm Innovation Hub, or our Drought Hub, to get a few more. And then that went so well that they gave us some more money for round 2, and we extended it out down through more of the agricultural significant regions in Tasmania, all the way down to Bothwell and also King Island, which just happened to be timely because they went through their driest period in 100 years. So we're able to capture that as well as in soil moisture, so to see where we were baseline in terms of pasture production as well, which is really good. So we grew that weather station network. The really cool part of that was that once we had that weather station network, there were either clients of ours who already had a weather station, or clients that said, yeah, that's cool, I really like it, but I want one closer. They bought their own and said, well, might as well add it to the network so other people can access the data. So that private weather station network, our weather station network, while the funding finished, it was growing for private weather stations, and it's kept growing for more private weather stations. We're looking to roll some out further down south, and goodness knows how far we can go. We can just take over the world if we keep working hard. But
please do.
Just on that very quickly for Jane and Josh. So obviously there, Marek's sort of saying private weather stations are coming into the fold. Does that make it more accurate for their neighbours, for example, if they were using James Weather?
It does. So what we've been able to show is the accuracy level we can get at that particular point where that weather station is a major jump up, or it's a major reduction in error. So that was that green bar I showed on the last graph there. Those who are in the surrounding area, we're also, by having that one point of data in that spot, we're also helping the forecast in the surrounding area. Not as much as you get by having that station right where you are, but at least it's a lot better than what just a standard forecast is. So it helps not just you, but the whole community.
Yeah, and in terms of that, so there's so many, like, so these weather state, these ones, these are all funded. And so what we did there was, we kind of went a bit differently. So instead of selling the hardware to the project and installing them, what we did was said, well, we're going to lease the hardware for the life of the project. So we're leasing it for the life of the project, which finished at the June, because what happens is you sell hardware to a project, there's ongoing costs, there's hosting and telemetry, there's calibration, there's servicing, all that kind of stuff that goes on. But once a project finishes, the funding finishes. So essentially the hardware goes to rack and ruin, and it just breaks essentially. So we said, well, instead of that, how about we lease the hardware? That does 2 things. Number one, that means we can get more out there, because leasing a bit of hardware is cheaper than selling it outright, because if we sell it, we've got to make margin, installation, all that kind of stuff. So we can get more units out there, but also what we'll do is once the project finishes, we'll take it on. So we'll then, because it's leasing, we're then owning the data. But what we can then do is the project finishes, but we can then go to a subscription model, and it's $150 to access your local weather station, which can then feed into Jane's Weather. So once you've got access to that, you can then subscribe to Jane's Weather and have that feeding in there. So it means that the project will not just go for the weather station, and the data capture won't just go for the life of the project. It will go for 5, 10, 20, and hopefully it becomes a really integral part of agriculture, Tasmanian agricultural, the landscape. So it just becomes you sign up to AgLogic and sign up to Jane's Weather while you're at it. I think it would be something if we get that rolling with the state, it just becomes that part of the tool in your toolkit. So as you skip back through that, and I was going through another slideshow I did when we first rolled out this project, and I just had a look came across this slide, which I've just cut and pasted on top of it, and the what next, and I spoke about innovation. The innovators are not us. The innovators are not myself. The innovators aren't, if I could be so bold, is not Jane and Josh. The innovators are the people using the data and using the information, because they're the people that go, hey, how about this? How about that? And then Jane and Josh, they're the ones that can bring that information and bring those solutions. So the people who use this, they're the innovators, not us. Obviously using it to improve production systems. But the last 2 points I had were, and this was a couple of years ago, were self-learning algorithms and forecasting. And here we are. So it was nice to go back in time and have a look. What was next? And when I put this slide together back then, I was just kind of, not pie in the sky, but it was almost just, wouldn't this be nice? It was almost my wish list, and well, some wishes do come true. So there you go. So using this information I think is really important. So we'll go on to the hardware side of things. I've played with that many different sensors, that many different bits and pieces to try and get the data. Price is always a thing that we try and get down. I'm always mucking around trying to put things together and see what works and what doesn't work. And essentially what I've come down to is you get what you pay for. We go to some true tried and tested sensors. You can see the one there, the weather. That's one of our weather stations that I was just setting up with the sun. In terms of there's a number of people around the country that do what I do, and we talk to each other. We're always bouncing ideas off each other, or talking about different sensors or different ways we can do things to make sure that we're putting in a sensor that will last and give you good information and good data. And essentially, you buy a cheap sensor, it's either going to break or it's not going to give you accurate data. So you look at those sensors there in the picture, and they're ones that we've really tried and tested. So reliable hardware is key. It gives you quality data, which is crucial, especially for those self-learning algorithms, and making sure they're calibrated and serviced as well. Because if you don't have any of that, you get this. You get no data at all. Now, that might, you think, yeah, so what? But it's not just in terms of the sensing and the hardware side of it. If you are relying on something and you get this blank graph, it leads to a mistrust of any form of ag tech or any kind of innovation, which I think is really important, especially for people new to this, especially for people who are going, okay, I'm going to put my foot out, my toe in the water, I'm going to put my neck on the line, I'm going to have a go. But if it just doesn't work, we just kind of go back to what we know, and we miss out on any of that innovation that can make a real difference for our situation. So making sure that's reliable is key, from putting the sensor in the ground or on a pole to having that information displayed in a way that you can help make decisions such as Jane's Weather. So that's enough about me banging on about hardware. I'll just briefly then talking about getting to know Jane's Weather. So this graph here so we've got Jane's Weather on a number of our sites down here in Tassie, and there was one weather system that came over us in June and July, late June, early July, which was a real good tester for Jane's Weather. Now here was our temperature down at Longford, which is 2 k's from the office. It was a very abnormal season for us. Usually we're a Mediterranean climate down here, and so we're very winter dominant when it comes to rainfall. And June and early July in particular were very blue skies, beautiful, calm weather. Usually we're cloudy, rain, and so we don't usually see this many sub-zero days. But as you can see this one here, you can see this one here in July, early July, we're getting down to -8.6. And I think actually Lyowini, not far from us, got the coldest ever recorded temperature in Tassie. But it was a high pressure system that just sat over us, really two high pressure systems, quite intense, just sat over us for the whole week. This was a period that we're really interested in. And here's a bit of this is the water tanks, the stock water troughs in the local area, nearly 2 inches of ice on top, which was, gave you a bit of an indication of what we were dealing with there. And it was actually, and talking to farmers, this kind of warning or this kind of helping us know what's going on, because burst pipes were a massive issue. So much ice formation that we had burst pipes. A lot of farmers only realised the damage 4 weeks ago when they went to turn their pivots on, and water wasn't going where it needed to go because solenoids had cracked or pipes had burst, things like that. So they're kind of things that can really help us. You wouldn't expect them. They're not things that you just that you have as a seasonal thing that you want to look out for. But this was one that really caused a lot of issues, not just back in July, but also now when irrigation season starts. So, yep, we got a rude shock from the frost, and so did all the weather forecasts, and Jane's Weather, along with everything else, predicted the frost and what was coming along. But it wasn't until that we got our first frost interval that Jane's Weather predicted the severity with greater accuracy than the rest of the predictors, which was really great to see. So once we got that first frost, it picked it up that yes, this is a colder spot than average. It's a flat, low-lying area that comes off the tiers, and so it picked that up where the others just kind of maintained their forecast, which was really good to see. So we spoke about frozen peas. We spoke about growing day degrees. So here in frozen pea production here in Tassie is a big one. It's plants are in the ground now, and we'll be getting harvest in about a month and a half to 2 months' time. We'll start. Now, what you can see is that graph behind was where with peas, they are fresh peas. We need to pick them at exactly the right time. So Simplot have paddocks all over the northern parts of the state, and they're planting, spreading them out so they've got a consistent harvesting window for their plants. Now, if you've got a seasonally abnormal hot weather, it can mature the peas a lot faster. Or if you've got areas which might have a microclimate that are warmer than others because of some certain reason, a region can set off a lot quicker than others. So what we're going to be using with Simplot, which is a large corporate down here growing in all fresh and frozen veggies. Spuds is a big one as well. Instead of using that table that's hidden by the tractors, what we're going to use is trying to use that forecasting for growing day degrees for that hyper-local forecasting. So we're using the weather stations that you saw in the map there, but also private weather stations. So they can try and predict what's going to mature sooner, because yes, pea quality at time of harvest is critical for what they can freeze and what they can use. But the big part of that, which again comes down to the cost, is moving machinery around. What they would usually do is they'd be going around sampling their paddocks, and they go, yep, right, this one's going to be ready in a couple of days. Let's get all the machinery there. And all it can take is a couple of hot days, and they can overshoot those peas. And so suddenly you do a couple of runs with the machinery and go, actually, we've missed this paddock. We've got to go somewhere else. So if you can actually make sure, even just within a small area, just going, we're going to reorder our paddocks based on based on what the weather's been or what the weather looks like, they can be a lot more efficient with their cost of moving machinery. So yeah, they're just a couple of examples there in terms of how we've been starting to use Jane's Weather, get confidence in it. I mean, that's one thing. I've been using models, and I've developed models for different things. I understand how useful they can be, but I can also understand their limitations and that they are fallible. So for us, getting confidence in that Jane's Weather was a big part of it, and we're taking that next step to use that in in a large scale setting such as that pea harvesting. So while I've got you, I'm just going to jump back onto the sensing side of things. Now, there's a on-farm connectivity grant round 2, which is coming out in the middle of November. Now, when I got distracted earlier, it was a message that came through one of the trusted advisors, so one of the guys that do what we do, who had also applied to be a supplier of this grant up in your part of the world, up in Mudgee, just saying that he just got approved as a supplier. So that was very timely. So that's opening in November. So what it essentially is it's a grant to help connectivity on farms. So weather stations, pumps, soil moisture probes, anything to help you improve productivity through digital agribusiness. So it's exactly what we're talking about now. Weather stations help you get a more localized weather data and weather forecasting that can feed into Jane's Weather.
So look, I'm very mindful of the time, but also Caitlin, we want to get to you because this is really about what that at the end when all this distills down, everything comes together, the hardware, the platform. How are you using the information that's at your fingertips in your everyday management?
Yeah, so we're down here in Tassie on the northwest coast, just outside of Devonport. So we're a predominantly vegetables, commercial vegetables for Simplot and McCain's, as well as fodder crops and livestock as well. So we jumped on board with Merrick in the early days and got a weather station put on our farm, which was great. As Merrick said, the pond was at the airport, and even though that's only like 5K away, there was still such a huge difference in what the airport thought we got for rain and what we actually got at our farm. So it was great to jump on board there, and then obviously that's evolved into using that weather station now for Jane's Weather to get very localized weather forecast for our farm as well. So for what we do, it's really important for timing of applying sprays, especially, sclerotinia in beans. We get a lot of disease, colour rot peas. We grow Brussels sprouts, potatoes, carrots, lots of different things. So everything is very different in the risk and the climate required for some of the diseases. So I get emails from Jane's Weather in the morning telling me what the forecast is going to be, if I have, frost risk, when's a good time to be spraying, all of that sort of stuff. So that's really important for us. Also for us, we do fresh care. So as part of our auditing system, we've got to prove that we have applied the chemical in the correct conditions. Obviously that it's not too windy, things like that. So there's a lot going on down here, but we really, really love working with Jane's Weather and also American AgLogic down in Tassie.
So,
Thanks, Caitlin.
Caitlin, you were able to set up just those alerts that were meaningful to you quite easily and then use them daily?
Yeah, definitely. So I've got the alerts. The main one for me is the wind for spraying, frost risk. We don't have to worry about that as much because when we've got the vegetables, hopefully there's not a lot of frost around, but it does happen on occasion. So making sure that, if there is frost coming, well, we know that we can apply some water with the pivots, to help minimize damage and things like that. The spraying conditions and also rain. We're heavily in our planting season at the moment. So what we're able to do groundwork wise is heavily dictated by the rain. Like we got 56 mil of rain last Friday, which luckily didn't do a lot of damage, but we were racing to get paddocks of spuds in before that. So it all comes into one.
Fantastic. Thanks, Caitlin. And Claire, I'm not sure if you're still there and able to have a quick chat about yourself and Sam have had access and been set up for about, I think it's about 10 days now. And how have you found it initially?
Can you hear me?
Yes, we certainly can. Go for it, Claire.
It's more my husband using it more so than me. We've only been on it a short while, but he's still getting used to all the functions and capabilities. But he did say he found it pretty accurate. He said, I think the words were spot on. He liked the timing, the interface, the layout, the traffic light reporting, green, bad, that type of thing. It's just easy for him to go in, oh, yep, good for spraying, rain's coming, okay. But also the cost-saving measures, like knowing what's coming with accuracy. Oh, I can reallocate these workers. It's going to rain here for 4 days. I'm going to put them on the other farm. It's going to rain for 4 days, so I need to get these leeks out. We'll put them in the cool room for a few days, and then we can work in the rain. And knowing that with accuracy really helps planning everything. Just everything on the farm relies on accurate weather predictions, and he's just found it really, really good.
Thank you, Claire. And just from me, it's so nice to hear that feedback from people using it on the ground. That's exactly why we made this. We wanted to make it easier for you guys to take advantage of the weather and sort out the problems before they arrive. And so to actually hear that what we're producing so far is useful, it puts a big smile on my face. So thank you.
That's good.
Great. Thanks, Claire. And like I said, that's only after 10 days. And I think for you guys, the fact that the Richmond station is pretty close is a real benefit. So yeah, look, thanks for that initial feedback. And we're going to continue to follow both Ed and Sam's experiences with it, and what decisions they make in having access to it throughout the rest of the duration of the project, so that we can just demonstrate to others how it might influence some of those decisions you're making on farm. And obviously with this project, a strong focus on how you're managing pests and disease as a part of that. So look, I think we better finish off now. We have gone over time a little bit. But I'd like to thank everyone for contributing today.